Welcome to ACM Shorts. Today's short is called Fix That Mix. The ACM Shorts where we show a concrete problem, troubleshoot what happened, and offer a solution to prevent it from happening again. These segmental retaining wall units, or SRWs, have not dealt with repeated exposure to freeze-thaw conditions very well. But we can also see this wall is next to a road, so it's also possible that heavy use of de-icing chemicals nearby has contributed to this, as de-icing salts can have a significant impact on concrete durability. Now, it's important to note that SRWs in many areas of the country are not exposed to severe weather conditions. Therefore, the situation above applies only to areas where repeated freeze-thaw conditions occur. This image is an extreme example, but if we don't take proactive steps to ensure SRW durability, this is what can happen in colder climates. We should mention that SRW freeze-thaw issues are much less common than they were back in the day, as producers have made adjustments to increase SRW durability. Let's unpack the relationship between concrete and freeze-thaw cycles. When the unit is saturated and the moisture in the unit expands as it freezes, tremendous stress is put on the aggregates in the cement binder, and if the aggregates or the concrete is not strong enough to withstand those forces, the unit may fail, as we see in that example. So what do SRW manufacturers in northern climates do to make durable units? Well, first, this sounds obvious, but they use freeze-thaw durable aggregates. Typically, DOT-approved aggregates will be freeze-thaw resistant. You can check with your supplier to confirm that aggregates are meeting ASTM freeze-thaw standards. Secondly, test to make sure units meet ASTM C1372 physical characteristics for the zone in which the units will be installed. This specification covers both solid and hollow units, which are to be installed without mortar, sometimes called dry stacked. These requirements are intended to assure lasting performance, little or no maintenance, structural integrity, and continued aesthetic value. Lastly, most importantly though, producers should aim for units with low absorption and high density. Dense units with tight surfaces and fewer interconnected voids will limit the amount of moisture that can be absorbed into and then through the unit. So, what can production crews do to increase density and lower absorption? Well, first, look at your mix design. Using multiple aggregates can help ensure that your aggregate blend will maximize particle packing and therefore increase density. Secondly, during mixing, add at least 75% of the water up front. This ensures optimum cement dispersion, hydration, limits segregation, and helps with unit feed and fill. Lastly, pay attention to the details and don't rush. This applies especially to irregularly shaped and hollow units where you need to ensure proper mold filling and compaction to minimize voids. Aim for 2 to 3 seconds of vibe time. I hope this was helpful, and we'll see you next time on ACM Shorts.